So let's say this should work. YouTube, don't let us down. Here we are. This looks good. All right. So, okay. Right. So muting myself helps here. So, hi, hi, Smile. How are you doing?
I'm cool. How are you doing?
Not too bad at all. Not too bad at all. Thanks, mate. So we are here to see your talk about Kotlin Multiplatform as a kernel. So far, it says 2 people watching, but I would say we would just start in a second and then people can catch up. Just a few words up front. As always, welcome. If you like it, push this share and like buttons and all these nice things. And if you have any questions, please let us know in the chat and I will make sure that the questions find their way to you, Smile. Smile, is it okay to, or how do you like it? Do you want to be asked at the end or just when the questions come up? What's your favorite?
Maybe you could take it at the end so
Yes.
we don't distract the flow.
Yeah, sure. We'll do. So I will collect them. And with this, I will just hand over to you and yeah, enjoy.
Awesome. All right. Okay. Hope you can see my slides.
Not yet. Give it a second. Started screen sharing. Come on. It worked when we tested it. It's still black. Here we go. Here we go. Okay, now it's yours.
All right. So today we'll be talking about Kotlin as a kernel. This basically describes multi-platform Kotlin. So my name is Smile. Well, Kotlin multi-platform, for one, is actually not all about just compiling code for all platforms, but it's actually about sharing code across all platforms. I know this might sound a little bit confusing, like, okay, you're saying you're not compiling code for all platforms, but I could give a brief example. A couple of years ago, what made Java quite popular was the fact that Java was able to run on all systems. And that was actually compiling code for all platforms because Java ran on the JVM and you needed to have the, the runtime on that machine for your code to run. But for Kotlin multi-platform, what we're actually talking about is writing code natively, but also being able to use platform independent APIs. So that's what we're going to really explore here and also explore how this would be beneficial when you're writing your programs or your apps. So one of the key takeaways within Kotlin multi-platform program is you reduce the time spent while writing the same code. I mean, if I wanted to write an app and I have both an Android app and an iOS app with a server backend, we spend a lot of time on creating modules, writing serialization code, passing JSON or XML, basically doing the housekeeping. And we write these same codes most times. We might end up running into bugs. But what if we could just write most of these housekeeping codes at once and we share them across different platforms, especially when we talk about things like the domain layer or the business logic. Why not we have these things in one place and we share them across these platforms? An important thing to also note is we could actually write our code in such a way where we have strict contracts that allow native implementation. If I have the domain layer written in Kotlin and I needed both an iOS app, an Android app, and probably a desktop app to actually share most of this domain logic, which isn't supposed to change, then basically I would actually share a common module and other platforms will actually implement these modules. So we'll actually have a deep dive into that so that just avoid all confusion. So this is basically the way we build our apps. We build our platforms. We have an API We will probably have a web front end, we have an Android app, we have an iOS app, and each of these platforms will write the same business logic. And when we're talking about business logic, we're talking about the shared logic across the platform, things that wouldn't change. If we're writing a fintech platform, then your business logic would probably be how you handle your deposits, how you handle your credits, how you do your housekeeping based on like how you handle your users, authentication, all those things would fall under your business logic, basically the rule set in your application. And we write our apps this way, and we think, okay, can't we actually have something better, or can't we have a way to reduce the amount of code we need to maintain? If we're going to write code that passes a certain module from the API, and we are going to repeat that same code within different platforms, why can't we actually be more efficient with this? And it brings us to the question is, what is the kernel then? I mean, we've really spoken about these problems we are highlighting, but those were more of like a digress, but let's move back to the actual topic, which is what is a kernel? A kernel we know is the center part of a platform. Or if you're going to think about agriculture, you could say the kernel is the center part of a fruit, or like the seed. And when we're writing our programs, every program has a center, it has a core, which would always define it as the business layer, or the domain layer, which has the business logic. And what we aim to achieve with this talk is actually to show how we could use multi-platform Kotlin as that kernel. Want to actually write our business logic and share that across. We actually want to write these things once. We actually want to create strict platforms or strict contracts that we would share. We have our illustration where we basically showing us that we could have a common Kotlin code, and we could share this code across JVM or Kotlin JS native code. Already, Kotlin actually has interop between these platforms, which allows us to get access to these APIs and write code with them. So we'll still have a deep dive into how this all works, but just keep it at the back of your mind that the common Kotlin, which is either at the center in blue, would actually serve as a kernel, which would feed the other branches of your platform or your program. Now, how is this really beneficial? Well, for one, we've spoken about shared functionality. If you are going to be writing your code consistently, if you're going to be writing the same things over and over again, it actually doesn't make any sense for us to rewrite the same logic. And we have native implementation. So as Kotlin developers, we already are writing Kotlin. And it's actually an added advantage for us to be able to write Kotlin and expose our Kotlin APIs to work on other platforms, and as well reduce the amount of logic we have to move around with when we can actually write these things once. And having a tight rule set, in multi-platform Kotlin, we have something called expect and actual. And these kind of define a contract between the different platforms. I mean, if you're going to be writing a kernel or the core of your program, you definitely need something that's going to tie up or make sure each platform adheres to this logic. Here we actually have like a simple process flow where you would receive an input from any individual platform. It could be your web, it could be your app, both Android, iOS, it could be your desktop, and we would process this data. And what we are looking at here to achieve is when you go to the part of processing data, it spreads out into the various targets or the various native platforms. It could be Android, iOS, Linux, whichever implementation. And after using the native implementation within this target, it goes back into the common code to perform an operation and then ends its execution. Now, it might seem like, oh, okay, so we are still writing individual code, but not necessarily. When you think about how platforms interact, we would always have some certain things that platforms handle differently. Example, when we are talking about IO operations, the way you would access a file on an Android system will be different from the way you would access a file on the iOS platform, and as well how you would access a file on your desktop machine. So if you received input and you needed to save, let me say, a file, you would need to now move down and look for the platform specific implementation of that. Example, like on Android, let's say you wanted to save some sort of cache, we'll be talking about using your shared preferences. On iOS, we'll definitely be talking about using the NS user defaults or the NS bundle. And on Linux or any desktop platform, probably you would create some sort of TXT cache file and save it within the hidden folder. And after saving that and processing whatsoever data you saved, you can now return back and continue your executions within the command code. So this just illustrates how one of the many possibilities where we are talking about having the kernel. In this sense, the process data, the perform operations, it could be any operation. These are actually like your business logic, and those actually form the innermost part of your platform. Different platforms actually adopt architectures in different ways. One of the most common forms of architectures we've seen, especially on the Android side, is where you have your presentation layer, your domain layer, and your data layer. And each of these parts actually have their certain rule sets. Usually the data layer would talk about framework specific code or implementations of interfaces from the domain layer, and as well probably implementations of BI objects. Then your presentation layer is basically the view, but the domain layer would always be fixed to be your business logic, your models, your interfaces. But we are thinking of doing something different if we are really planning to make use of the power that Kotlin is providing us, especially when you work in industries where you have to develop on different platforms, and we're trying to cut down not only the development time, but as well ensure quality across what we do. So we actually have to think of this in a different way. Instead, each platform would more or less only create a presentational layer. If we're this to be a desktop, it would probably be maybe, I don't know, some web, some desktop UI. I think like maybe Swing or one of these JavaScript frameworks that is on the front end for desktops as well. If it was to be the Android side, or you would know you would be creating your view using your view model and your fragments and picking data off from the multi-platform library. And as well for iOS, you just be creating your view controllers. And this is really what we aim to achieve with Kotlin multi-platform. We have within here, we have the expect interface. We have interfaces, we have the common module here, and we have the actual, which will serve as picking our framework code. And this would actually serve as both the domain and data layer. If I take a step back, you could see that here we have different layers, and every platform would probably implement this in a different way, but we would all agree that we would have some sections like this. But in this case, we would leverage our multi-platform kernel to actually take care of this common logic. And actually what would change is the presentational view. So we let each platform define their own presentational view, but we are actually quite certain that the data we'll be getting will be the same across all platforms because it's more or less the same code. And yes, so our domain layer might be our common module across all platforms, and as well, data layer might be the native implementation for our expect methods. Now, if you remember very well, in Kotlin Multiplatform, we have what we call the actual and expect. We just help us define contracts across different platforms. So we could say our data layer would actually form as these implementations for the expect methods. And this actually forms a part of saying we have a shared architecture across platforms. So all our different platforms actually do is just present a view or create a view that receives more or less the same data. I think the highlights of today is I would like to walk through a case study. Um, some years ago, maybe 2 years or so, I wrote a toggle feature library for a previous company where I worked with. And I actually used, I think that was one of the times I really fell in love with Kotlin Multiplatform. And the goals of this library was wanted to create an app config, and as well, we needed configurable properties. We were planning to launch in different countries, and we really did not have the manpower to develop feature flags across all our platforms. So we thought, okay, is there a way we could actually write this once and share it across our platforms? And that's when the whole idea of using Kotlin as more or less creating libraries came in. The specification were, we had both an iOS and an Android app. So the specification was for the Kotlin multi-platform project to export the .framework file. So the iOS devs could import and as well export the .aar file. So the Android devs could as well import. And we were planning to use shared preferences on Android and NS user defaults on iOS. As well, we included a default bundle within the apps. On iOS, I think this was implemented using NS bundle. Then on Android, we were able to just bundle the resource. We can say this is basically the data flow or a process diagram of what we wanted. The platform dev, which is basically our server, would send down a config, and we would have a catch file. And if present, if the cache file is present, we could return that depending on the timestamp. And if it's old, we could resave the server config and send it down to the toggler library, which will now save that file. And we would use that we would actually use that for the feature flags within the app, which actually sounded quite good in a way. So let's see how we actually went about this, so we don't really tell too many stories. And so the setup, when you're actually creating a multi-platform project, especially for this use case where the plan is to export libraries, which is the .framework for iOS and .air for Android. And as well, you could actually still export other native binaries for other platforms. You just have to specify that. We first of all, within our Gradle, we actually define those targets. For you, we wrote, we define an Android target and an iOS target, specifying that we will want an output of that framework. Now, the beauty of this is you're actually able to customize your target and your implementations. You can actually have multiple targets for the same platform, but different outputs, which is kind of nice and intuitive. The real takeaway is, I think the more, the better you are at Gradle. I think that's where multi-platform really works for you. But the JetBrains team they've actually done a very good job in creating a lot of these presets, because most of these are actually predefined. So you just have to take a pick. If you move on to the Kotlin website under the multi-platform section, you'll see a ton of presets already there. And something to note is the Kotlin native compiler actually comes with some common libraries from the iOS and some other platforms. So you wouldn't have to worry yourself about, oh, okay, how do I import most of my favorite Cocoa pods, or how do I import most of my favorite libraries? So this is just for the targets. And you would as well have to define your source sets. Now, in the library we created, we actually used the Kotliners serialization, because this actually was easy to work across the different platforms for serialization, instead of having to define different serialization libraries. Like, I know for Android we have a couple like JSON, Jackson, and the rest, but we had something that was from the JetBrains team, which was quite superb and as well very simplistic. So there was really no need to actually bang our heads and start looking for something else. And if you take a look down at the iOS main source set, you will see that we have the runtime native. So this is actually the native implementation of the Kotlin X. If you are going to also run this on another platform besides iOS, you would also include this dependency. So the point of this slide is just showing you how to actually set your different source sets. And as well, there are a ton of presets for this. Your Android main, iOS main, you have your JVM main as well. There are a ton of presets already predefined by the JetBrains team, which is also quite nice once more. Then we come to the actual and expect. We've been talking about actual and expect a lot, and at least now we finally get to see a little bit about what this entails if maybe you didn't already know how this was. So like the way actual is what a thing is, and expect is I expect this to happen, or I expect to find this here. And in Kotlin Multiplatform, you basically define your expects within the common module, and the actual declaration or the actual code itself now goes into the native source sets. If I take a step back, you can see we have some source sets here. So that is where you would actually now write the code for the actual. Now, when you are compiling a code, it would actually now look between these different source sets and try to see if you fulfill the contract. So this is one of the key takeaways when I spoke about making your code safe across platforms. If you are going to define a set of parameters and say, okay, I need this method and this method and this method, it would make sure each source set that has that file is already given an implementation for that. So I expect this, and it should be there, if you want to put it that way. So this is an example of how we actually defined our own class. So we knew we needed to write to a cache. We know we needed to get a default in case maybe a server failure. As well, we could get the config, get cache, save the config, and restore a default. Maybe we are trying to reset. And we included a companion object where you could actually initialize the class. So this is actually just an expect class, and we are going to see the actual implementations in just a minute. We spoke earlier that Kotlin actually favors specific APIs for implementation. So you're able to write your classes and use native code to actually fulfill those contracts. Here we actually have, this is actually the iOS part. You can see where we use NS user defaults to get the config objects and ping it into a config object. And over here, you would see the same thing, but an implementation for Android instead. So if I could go back, you could see under the get config method, you could see we are using NS user default, the standard user default. This is actually an iOS API. And we convert the string we get from there into a config object. We actually wrote a Kotlin extension within the common module for that, so we can still call the common module code from here. But for Android, you can clearly see the difference. Instead, we're using get shared preferences and all living within the same project. So it just shows you how you can actually define these things across platforms and still use your platform APIs to actually fulfill the contracts. And for the constructors, we have our iOS constructor, which takes in a country string, as well the Android also takes in a country string, but as well takes in a context, which is very important for creating a shared preference object in Android. Now, these two are actually consuming the same API from the common module, but they are able to define how they'll be created. They're able to define their platform-specific code just for them to be able to fulfill this contract, which is really how this really shows how powerful like Kotlin Multiplatform can be, and how it really helps us to actually write code that would be the center, or as I would say, would be the kernel of our programs. I mean, if you could actually write code once and be assured of the implementation across your different platforms, then that would save considerable amount of time. As well, we're just looking at a couple more examples on how we get our default. On the Android, we're actually using a buffered input stream. We use context to access the default asset. So we have a bundle JSON file. So we need to actually use the context. And that's why within the constructor, we had to add a context to that. But on iOS, we have something completely different, but it's still the same API provided by the common module, but just a different implementation allowing us to write native code. In the iOS, we use the NS bundle and look for the path for that same JSON file. Just different implementation, but the same work. And if you remember when we spoke about the domain and data layer, we could, in a way, say that the actual implementation would serve as the data layer because that is more or less framework-specific code, and that provides an implementation to the domain layer or the common module. So in this sense, our common module will act as the domain layer or the business logic, and the platform targets would now serve as the data layer. So the kernel, in this sense, will now be a combination of the domain plus data layer, which would be a combination of the common module and the targets. And in our case here, the targets are the iOS and Android parts. Here is just a sample of the extension written using Kotlin X realization, taking in a string and changing that into a config object. And just to highlight, Kotlin X serialization library is really, really easy to use. It is very straightforward with little overhead. Just not to talk too much about it, but I think it doesn't use reflection or so you have a little bit of that overhead away. So what are the key takeaways from this? Well, we could say it saves time on code maintenance. If everything is defined in one place, then you would know that it's easy to maintain. If you have an error, if you have a bug, you know where to look for. Not like we won't be able to debug, but at least fixing something in one place and not having to scour in multiple places, because we have this common problem where probably on iOS, someone does not define the model very well, probably a typo or something, app crashes. And on Android, someone has that same issue, but probably for a very different property. Well, in this case, you fix once. As well, you could also argue that if it breaks here, it breaks everywhere, but well, we'll just hope to be a bit more careful. As well, a single language, you would see that almost all your devs could actually be writing a single language. I mean, Kotlin also works on the back end with Ktor or even Spring. So if you were doing this, you would know that everybody writes a single language, both on iOS, on Android, on the back end, and even on the front end using Kotlin JS with one of the front end, maybe with Electron, because I think I have seen some implementations where people have used Kotlin to write Electron into the desktop. So having a single language, it's really cool because everybody can learn from each other within the company, and as well, code reviews will probably go a lot smoother and not have limited people for that. Then reduce potential for human error when you have multiple moving parts, like the earlier example about your API codes. When you're trying to write code to pass your API objects, like I think this is a very common source of most bugs. You keep wondering why the app might be crashing, but you forgot maybe you were supposed to define some enums, and you didn't, or you forgot one and you're having a pass exception. So when you reduce the number of moving parts across the platform, it actually reduces the potential for human error, since everything would probably be defined within our business layer or our domain layer. So we would be sure to catch those things in one place. And I think for me, the best takeaway here is it's Kotlin. So yeah, I think that's the biggest takeaway here. We get to write Kotlin in every place. And as well, using most of the Kotlin superpower like simplicity. null safety and the rest, I think that is also a very important takeaway to exploring using Kotlin multi-platform and writing using Kotlin to write libraries. I would say for me, this might be a very nuanced opinion, but I would say using Kotlin multi-platform would be best in a way to create multi-platform libraries that you could share across your platforms. So, the other platforms, all they have to do is write presentational logic or basically create views, animations, and, the data that comes in is the same across board. So I feel that is where the power of multi-platform really shines. And well, these are just a couple of links you could check out. And as well, the first link there is actually a link to the library I wrote or the one I used as a demo. So you could also check that one out. And I think we could have questions. But
It doesn't look like it so far. And I think it's a new record in 30 minutes through the talk. No worries, absolutely fine. So let's give the audience a second or two to catch up. So maybe I just throw in some questions. So you said that you wrote this example for one of your previous companies. So did you follow up with this kind of example or with this idea of seeing MPP as a kernel and then maybe even going forward with the example and building it more out and towards a more generic approach afterwards, or is this still something which is just part of your previous company's software portfolio?
Oh, okay. Well, this is more or less an extracted form right now. So it would be very, very easy for anyone to actually modify at the current state. But no, it's not too generic. Right now, it's more or less tailored to feature flags. So I kept that idea at the center of this project. But as well, I kept it this way also as an example for anybody looking to quickly have a deep dive into Kotlin multi-platform. Because I think when I started out, the major problems I had was the setup with Gradle, kind of setting up the targets, the presets. Yes, we have everything there, but really knowing where to put what was more of a confusion. Yes, like I know from the IDE, you could have the quick setup, but for some reason, after you do the quick setup, you still have to either delete a few things or add a few custom things. So I really just kept this library just to help anybody um, just have a quick start. And I didn't include it here, but I do have another library on Kotlin X serialization. But if you do check the same my GitHub, it would still be there. So like there's two of that. So whichever one that seems easier for anybody as a quick start.
Sounds great. We got the first question, which comes from Christoph, and it is: do you know if the Kotlin X serialization is binary compatible between the platforms?
Oh, okay. So not exactly. That was really, if I get the question correctly, that was really my first hiccup. You would have to, yeah, you would have to include the native. Maybe if I could go back a little, there it is. So there's a native runtime you'd have to use across platforms, but besides on Android, so for other native platforms, you'd actually have to include the runtime dash native. So if you were, say, to have a Linux preset here or a Linux offset here, you would have to include a runtime dash native for that, unfortunately.
All right. Yeah. Sorry, I had to laugh, but it's always some. It's funny how questions sometimes just hit the exact spot, which is like you have this huge thing you did, and then you had this one issue with it, and the first question is like this just hammer on it.
Just
Anyways,
it down.
yeah, no, it's fine. Do you have any good recommendations for how to start with multi-platform?
Oh, okay. So the best way to start with multi-platform, I would say, is to actually have a look at the Kotlin.org. Number one, that is a must go to. Number two, I would say just have a little bit more of a read on Gradle if you haven't already. Yeah, I think the Gradle setup for Kotlin multi-platform, it's not the best, I would say, but it's still cool, but it's not really the best because there are also really little intricacies you would need to define, maybe to have some more custom things, but it might not really be necessary. And so number two could just be optional. Then number three, there are a couple of sample libraries as well provided from the JetBrains team. There's a starter library there as well. You could just download and have a look through it. And as well, I think the previous Kotlin Conf app was written with Kotlin Multiplatform. Though looking through it might be a little confusing at first glance because it's actually a full-fledged app, both Android, iOS, written completely in Kotlin, both views, models, and so if I'm not mistaken. Yeah, so yeah, I think with that and with your knowledge of Kotlin, definitely yeah, you can jump in. And if you want to do anything further, you could look at Kto as well. So maybe you want to write something for the backend and want to explore, you share these things across. So yeah, you could have a look at that as well as Kotlin JS.
Perfect. Sounds good. So what I will do is when you send us the links again, I would love to have the links to the presentation and to the repository and all the things you just had on your slide
Awesome.
down in the description as well. And yeah, so where can people find you if they want to talk to you about this or about multi-platform?
Okay, I think I'm easily accessible from Twitter. Here it is, and I do a bit of writing on Medium, so you could check out my articles. If there's anything you don't like, you could shoot in a comment and like, why did you write this? So yes.
Perfect, thank you. Then a little bit of admin at the end. Totally selfless. So I'm part of the organization team for Java Advent as well. So we do original content for the first 24 days in December. Why 24? Just do the math. And we are looking for authors this year. So everything which is JVM related. Personally, I would love to have as many Kotlin articles as possible. If you want to help us out, or if you want to have your content, or if you have an idea, just get in touch. So you can find me on the Kotlin Lang Slack, and there is a link in the description as well, I think. And otherwise, just go to javaadvent.com. And if you want to be on air as well and just do an amazing presentation as Smile just did, please get in touch as well. We're always looking for great topics, and it doesn't need to be long. It can be longer, it can be short. Just get in touch. Again, best place is the Kotlin Lang Slack, but also Twitter, and all the other channels, I think LinkedIn and Facebook and all these things, but best would be Kotlin Lang Slack. In this sense, or with no further ado, I would say to everyone, have a great evening if you're roughly the same time zones as we are, and have a good one, and we hopefully see each other soon to our next session. Thanks.
Awesome. Thanks.